Hi there, welcome back. Thank you to everyone who is participating in the conversation over on the Twitter sphere at World Summit AI, hashtag WSAI20. So for our next headline speaker, she's going to be speaking us today about decision intelligence, making better decisions about AI's decisions. We'll be hearing from Kimberly Nevala, the strategic advisor of SAS. Her role encompasses market and industry research, content development, and provides counsel to SAS customers and prospects. In a nutshell, she helps organizations understand and gainfully exploit the business potential of emerging technologies such as AI and machine learning. But her focus isn't just on technology, it's also on the cultural, organizational, and business changes required to make it all work, which we love to hear. So I can't wait to hear what she has to say. So over to you, Kimberly.
All right. Hello, everyone. Thank you so much for joining us today. All right, let's get that up. As we talk about the rise of decision intelligence. Now, as you can hopefully see, this is my road bike. It is leaning artfully against the side of my garage. Now, when I bought this bike, I had an objective. It may have been more of a vision of being one of these cool cyclists that I see whizzing along the road where I live. I was going to compete in triathlons and bike to get my morning coffee on the daily. I did not perhaps consider enough the decision points I would encounter on a daily basis that would influence whether I did in fact use my bike regularly. I also didn't consider the challenges that I would confront that in some cases would scare me back off the bike for periods of time. And that included things like the uneven roads and potholes in my area, the rain, I live in Seattle, and the fact that I'm a perfectionist. And my desire to ride up the big hills that are prevalent here and the ability I really wanted to be able to ride them up with ease was sadly in conflict with my athletic prowess. So had I taken a more deliberate approach to thinking about not just what my objective was, but how and what I would need to do to achieve that objective, I might have bought a cheaper bike, or my bike might actually have more miles on it and the tires may not currently be flat. Now, why do I start here? Well, when it comes to AI, the technology is readily available, and it is relatively simple to identify a lot of problems that AI could solve in any organization. But it is much, much harder to identify which of those problems you should actually solve and what will be required to ensure that the solution actually achieves your objectives and delivers the outcomes you desire without running afoul of the risks that are inherent in AI models. Right? AI systems are probabilistic. These are learning systems, and they are exquisitely sensitive and sometimes overly responsive to their environment, by which I mean the data that they're trained on and the data that they're exposed when they're deployed in production environments. And they will make mistakes. So to deploy AI effectively, you can't just understand the general capabilities. You have to understand how those capabilities apply in a specific context, what the limitations of the solution are, and then design how to deploy that in the context of that problem itself. So decision intelligence, which I'll sometimes refer to as DI, has come along to help organizations move past simply understanding what AI can do for them to really identifying what it is that you should be doing and in what context. And in fact, Gartner recently predicted that by 2023, over 33%, so 1 in 3 of large organizations will have analysts practicing decision intelligence, including decision modeling, to help data and analytics leaders and executives design, model, and deploy what they call decision models and processes in the context of business outcomes and behavior. So simply put, DI here helps determine what decisions we should apply AI to and how those decisions will in fact be carried out on an ongoing basis. Cassie Korsakoff, who is in fact, her title at Google is Chief Decision Scientist, has been one of the maybe most public and influential faces in driving this concept. She says here that decision intelligence is a new discipline for leadership in the AI area. And ultimately, definitions vary slightly, but they agree on a couple common points. DI is an interdisciplinary approach to making better decisions in uncertain conditions. And it brings together the aspects of data science with social science and traditional decision or management practices. So this includes things like psychology and behavioral economics, along with disciplines such as decision modeling and those core analytics and data practices such as data science, statistics, and even decision support. Now, in some ways, I find this interesting because it's a formalization of the diverse and collaborative teaming models we've talked about as a critical success factor for advanced analytics and AI and data science for quite some time. And DI is also a key enabler of ethical and responsible AI. Now, as is the case, not everyone agrees, both with the concept and in some cases just with the title. So as this gentleman says, decision intelligence is where AI, so DI is where AI goes to die. Might be a little bit extreme, but I appreciate the analogy. And some of the argument here is that this is really nothing more than pseudoscience or a pseudoscientific field that is putting a new name to what organizations have always done and what they've always done with or without AI. And that is to make decisions and take action. And it's true. It's certainly been argued or stated that artificial intelligence is not necessarily intelligent at all, and that the application of AI does not implicitly guarantee that any organization's decision-making, whether it's augmented or automated by AI, will in fact be any more intelligent or lead to better outcomes. And I think there's a kernel of truth in that statement or in that line of reasoning. But far from, I think, making the case against DI, it actually makes the case for DI. Because even if you regard this discipline, or maybe more appropriately the title that's been applied to it, as a thinly veiled attempt to teach an old dog new tricks, or maybe just dress him up in a panther's clothing, AI deployment does represent very novel challenges for most organizations. The ability for AI to make both good and bad decisions at scale and to act out, somewhat like your toddler or a teenager, in sometimes unexpected ways, means that we really do have to apply more rigor to how we approach these solutions in order to deploy them fairly, safely, equitably, and responsibly. And the truth is that as data and analytics professionals, we have traditionally delivered models or insights as standalone products. Right? We started way back with dashboards and reports. But today, advanced analytics and AI solutions are embedded, they're integral and integrated into our core business processes and our products. You can't deliver your customer service or take the AI out of your customer service chatbot. You can't remove the advanced analytics from your predictive maintenance service offering. So this means that we do have to not just create the analytic model, but we have to model and plan for how that analytic model functions within the context of the ecosystem in which it is deployed. And without that discipline, organizations will continue to either languish in pilot purgatory, and they might, as a number of recent research has suggested, start to actively slow or pull back from AI adoption due to concerns over perceived and emerging risks. You may find yourself scrambling to get yourself out of hot water when a deployed solution sort of goes out of bounds if it's deployed without adequate protections and guardrails. Or you may be struggling just to gain adoption. And I think it's important here to realize that this can be true even in the case of applications that don't trip any ethical or responsible AI alarm bells. So if we think about applying an AI algorithm to help us optimize retail stockout options, so to help us decide what to do about merchandise that's just been sitting on a shelf unsold for a period of time. Now, I don't think applying an AI algorithm to optimize this problem is inherently unethical. Probably no one would argue that point. But will the store manager actually follow the algorithm's recommendations? Well, the answer to that question actually depends on the extent to which the algorithm's outcomes align with that manager's outcomes and incentives. So if the AI is recommending an action, so throw the stock out, that's in conflict with the manager's and the employee's incentive, which is to maximize sales, even if you have to sell it at a discount, even if that may not be profitable, we have a problem. So in this case, putting AI into practice requires us to manage change, and that has to start with modifying that manager's incentive plan. And all of that together, with all of that aside, AI is an expensive tool. And it's one that, similar to that bike, which is currently sitting in my garage, requires ongoing maintenance from the moment it gets on the road to the moment until you actually hang it up for good. So we really need to make sure that we're directing our AI efforts towards problems where the value and the outcomes that we're delivering are proportional to the effort that's required. And all of this means that we have to make better decisions about the decisions that we ask and deploy AI to make. So what are the kinds of questions that decision intelligence helps us sort of think through? The first question is, what is the intended outcome? A simple question perhaps, but one that we don't always think about critically enough. But more importantly, we want to identify that outcome in a specific context. And we don't want to just define the process, who, what, when, and where, what the actions we're taking, but really clearly identify what are the decisions that need to be made in pursuit of that outcome. So for instance, if we want to optimize the delivery of goods using our truck fleet or logistical fleet, there are a lot of discrete decision points embedded into that problem. How many trucks do we need? What kind of trucks? How should they be loaded? Which trucks need to be taken off for maintenance when? What are the optimal routes and routing? And once we actually identify what those decisions are, we can now start to think really mindfully about what factors inform each decision. So we'll take an example from, for instance, using artificial intelligence to help optimize participation in a medical clinical trial. The questions we might ask are decisions we have to make. Which patients do we want to include and exclude? Well, to know that, we have to understand the patient's clinical history, what their current diagnosis is, what their burden will be for participating in a trial. We have to decide where are we going to recruit, in what areas, patients for these trials. And to make that decision, we have to understand what's the disease prevalence in a given population or area. What's the competitive landscape? Sounds a little odd when we're talking about medicine, but are there other similar clinical trials for similar conditions that are being offered that organizations might be on, et cetera, so on and so forth. So this starts to inform a little bit about what information and data we need. And for each of those decisions, we can now think about what actions might be taken as a result, and how does this decision interact with other decisions. Now, it's important here to know that we're thinking about data inputs and implications and system interrelations, but also human inputs. Is this a situation where additional human knowledge or insight is required to take or inform action? Medical diagnostics are a great example of this. And AR enhanced maintenance is another example where human and machines have to work together. They're not independent of each other. So these are examples of the types of questions and deliberate thought that DI helps us to make. And if we do this right, decision intelligence helps us do two things primarily. One, it helps us identify the discrete and atomic problems that we can solve for with AI. And it ensures that we're not just identifying those problems, those decision points that AI might be able to augment or automate, but it ensures that we're focusing on the decisions that are the most valuable or important. Secondarily, it really directly informs how we design and deploy the solution. Everything from what the business process needs to look like, what the data requirements are, what the technical deployment has to look like, and the guardrails that need to be put in place. What are the checks and balances? To how do we approach driving adoption, ensuring fairness, and creating accountability? Ultimately, I do want to, well, let me just take a quick step back. I think it's important to say here that decision intelligence isn't going to stop us from making bad decisions ever. And the algorithms are still going to make errors, but this is a hedge against those risks. It ensures we've at least tried to think about and project what some of these outcomes will be. And we've got a semblance of a plan minimally to address these errors and risks when and if they occur. So by baking appropriate collaboration, controls, and checkpoints into that AI lifecycle, we will ensure that deployed solutions are governed, that they comply with your internal principles and policies, including the covenants you've made with your employees, your partners, or your customers, as well as compliance with external legal or regulatory requirements. This is also going to make sure that we are starting with the end in mind, that this solution is customer-centric, that we're clearly defining and understand who that target customer is or what the target environment itself is. And this is important because one of the places that we fall over a lot with AI is coming to find out that the target population or the environment that we want to deploy the solution for or to is not actually reflected in the data that we have available, that the information we need or the distribution of the information that's represented doesn't actually reflect what we want to do in production. So a very simple algorithm, and it's something we've seen in the pandemic, if we have an algorithm trained to predict medical outcomes, and it's predominantly based initially on an older population, it might not be as accurate when it's applied to younger cohorts. So we need to know that, and we can then make the decision, is this appropriate to deploy the solution at all? Should it go out at all? Under what conditions or caveats should it be used? And do we require additional data or information before we proceed? The other context here, or concept, is what perceptions might impact how the solution is received. So despite increasing sophistication, chatbots aren't known for their bedside manner. So engaging them in conversation with an irate customer might not be the best option. Now, the next thing that DI does is it makes sure that we are evaluating solutions in context. So we know that the decision boundaries are clear. We know what we're deciding, but also why we're deciding it. Kassi-Korsakoff uses the example of cats, right? Are kittens and lions both cats? Well, you can probably think of situations where the answer to that question is either yes or no. Yes, a lion's a cat, or no, it's not, depending on the context and the application in mind. The other thing that DI helps us do is ensure that we're making good decisions on applying it, AI based on the intended application and not just the underlying tech. So we know that there's a horror story every week, hiring algorithms, for instance, biased against women. And this can lead to some gross generalizations to somewhat nuanced problems. Statements like, we should never use gender in AI decision-making. Well, certainly this is true when we're making hiring decisions or identifying or predicting someone's potential. But gender might be important. In fact, it might be unethical not to use it when we're trying to diagnose or predict someone's propensity for a heart attack. So these are decisions that have to be made in context. And ultimately, DI allows us to build confidence by facing uncertainty head on, by addressing potential for positive and negative outcomes, and ensuring that we understand the limits. Because if we understand the limits, we can identify not just if, but when we should use AI, how it will be deployed, and how we will monitor and correct for its performance. We can also make better decisions to balance global and local objectives, weighing, for example, the benefits and risks to an individual against a population collectively. And finally, DI ensures that our solutions are transparent, that all relevant or effective parties have been consulted or at least considered, and that there's clear accountability for the outcomes that we're delivering, and we have mechanisms to identify and remediate harms or error if, not when they, actually when, not if they occur. So all of this together is really to make the point that by bringing together data science with social science and good managerial and decision support practices, DI helps us keep AI on the road safely and continuously. Thank you.
Thank you so much, Kimberly. That was really insightful. And I loved the framework you gave. I think that's going to be very helpful. I'm sure some people have questions for you. So if you want to click on the link in the chat box, this will take you over and Kimberly can answer some of your questions. So thank you very much.
Thank you.
We're going to just take a very quick break, get our panel lined up to talk, and we'll be right back. Thanks.